Alrighty, compound interest formula. So, you probably remember this from year 10. It is A equals P times 1 plus R to the power of n, where R is the interest rate per compounding period, usually written as a decimal, or you could write as a fraction. They're interchangeable. N is the number of compounding periods. P and P is obviously the amount that is invested. So it's really important that the interest rate and the number of time periods match the compounding period. So that means if interest is being compounded monthly, you want the interest rate to be a monthly rate and you want n to be the number of months. If interest is being compounded yearly, you want a yearly interest rate and n will be the number of years. Alright, now the compound interest formula is essential that you memorise, because not only is it going to be used in today's lesson, but we're going to build up some series for annuities and loan repayments with it. It is an extension of the simple interest formula, I equals PRN or I equals PRT. So simple interest is when you might hear the interest is charged at a flat rate, and then if that gets credited to your bank account at the end of the month, then the next month you'll earn interest on top of that interest. And so that's what compound interest is. Compound interest is interest on top of interest. Okay, let's have a look at some examples. In this first example, Karen invests $900 in a bank account. Interest is compounded monthly. It's really important that you underline keywords like this. At a rate of 10% per annum. Find the amount of money in the account after 2 years. Okay, so P equals $900. Now, interest is being compounded monthly, which means we want R and N in terms of months. So now our rate is 10% per year, which is 0.1. We want to change that to a monthly rate. So because there's 12 months in 1 year, we're going to divide that by 12. Okay, and let's just see if that becomes, that comes out to 1 over 120. As a nicer little fraction rather than having a decimal in the numerator. So n now is the number of months. Well, we've got 2 years here. There's 12 months in 1 year, so in 2 years there will be 24 months. Oops. Alright, so this is for question 1. So the question is asking us to find the amount of money in the account at the end of the 2 years. So that's what A represents in the compound interest formula. A is the amount at the end of the compounding period, including the principal and the interest. So it's going to be 900 times 1 plus R to the power of n. Alright, so just putting that in your calculator. 900 lots of 1 plus 1 on 120, all to the power of 24. Which is 1,098, and because this is a money question, we are going to always round our money questions to 2 decimal places, because that's going to be to the nearest cent. So the amount of money in that account at the end of 2 years is going to be $1,098.35. Alright, let's have a look at number 2. Aya invests $5,000 with interest compounded quarterly at a rate of 12%. Find the value for investment after 5 years. So our principal now is $5,000. Our interest rate is 12%. Oh, that should have said 12% per annum. I missed that in the question there, sorry. So 12% per annum. So we are going to change that to a quarterly interest rate. There are 4 quarters in a year, so we need to change this to 1 quarter by dividing by 4. So 0.12 divided by 4 is 0.03. 3%. 12% divided by 4. You can think of it in percentages if it's easier than decimals. And n is the number of quarters. So in 1 year there is 4 quarters. So that means in 5 years there's 5 times 4, or 20 quarters. And so this question is asking us to find the value of the investment at the end of the 5 years. So that's A, that's what we need to find. And that's equal to P times 1 plus R. This time, instead of writing plus 0.03, I'm just going to combine them together like that. And that's what we're going to end up doing in a lot of our series questions. To the power of n. Alright, and so then just putting that in your calculator. Power of 20 is $9,030. Wow. 5,000 times 1.03 to the power of 20. Cool, $9,030.56. That's pretty good. I guess that's a pretty good interest rate, 12%. What are interest rates at the moment? Not that high. Alright, let's have a look at... Tom invests a sum of money at 4%. This is missing some information again. Over 6 years. We'll pretend that says 4% per annum. Sorry. And he has invested $3,163 at the... Tom invests a sum of money at 4% over 6 years. And he has $3,163.30 at the end of the 6 years. So that's the final amount that he's got in there, A. Okay. How much did he invest? So the question is asking for the principal if interest is compounded yearly. Okay. So our simple interest formula is A equals P 1 plus R to the power of N. Now, because interest is compounded yearly, that means we want our R and N in terms of years. And we've already got that in the question. N equals 6 and R equals 4%. Or 0.04. So that means we don't have to change any of those because they are R and N are in terms of the compounding period. So what we need to do is we need to substitute into this formula, and this time the question is asking us to find what P is. So they're giving us A is 3163.3. We need to find what P is. 1 plus R is 1 plus 0.04, which is 1.04 to the power of... It's supposed to be a decimal point, to the power of 6. It's hard to do decimal points on here. Alright, so to solve this for P, we need to divide both sides of the equation by this big thing. So we've got 3,163.3 divided by 1.04 to the power of 6. That's going to give us P. So 3,163.3 divided by 1.04 to the power of 6 equals $2,500 and 00. The next digit after that's a 1, so that'll just be $2,500. Okay. What is the interest rate? So this question now is asking us to find R if a $6,000 investment, so that's P, is worth $8,463.59, so that's A, after 10 years, and interest is compounded yearly. So compounded yearly, that means we want R in terms of years and N in terms of years, which is good, we've already got that. So, using our formula, I'm just going to substitute into that. So A is $8,463.59. And that equals P, which is $6,000, times 1 plus R. Remember R, we don't have, that's what the question is asking us to find. And then to the power of 10. So, to solve this equation, the first thing that we need to do is divide both sides by 6,000. And then we'll get 1.41. Some other digits there, which we will keep in our calculator memory for now. So 1.41 ... is equal to 1 plus R to the power of 10. Now, remember when you have, say, something squared, the opposite of that is the square root. When you've got something cubed, the opposite of that is the cube root. So when we've got something to the power of 10, the opposite of that is the 10th root. So we're going to do the 10th root of both sides of this equation. And then you can see on this side that the 10th root and the 10, they are opposite or inverse operations. They are going to cancel each other out. So you'll just be left with 1 plus R on the right hand side. On the left hand side, you'll type in your calculator, shift, and then the nth root button, type in 10, then press answer. Alright, and you'll get 1.03499 something. So that's what 1 plus r is. So that means we need to minus 1 from both sides so that we're just left with r. And we are left with 0.03 4999 something. So that's our rate as a decimal. So to change a decimal to a percentage, you multiply by 100. So that is going to be 3.49 or 3.5%. And because our interest was being compounded yearly and our n was in terms of years, that means our rate is also a yearly rate. So we'll put per annum at the end of that. Alright, so that's number 4. Number 5, Brett invests $5,500, so that's P, at 6% per annum, that's R, with interest compounded yearly. After how many years, the question's asking us to find N, is this investment worth $8,269.97? So that amount there is going to be our A. So, substituting into the compound interest formula, we're trying to solve this time the equation for N. So, A is 8269.97. That's going to equal P, which is 5,500. Brackets, 1 plus R. Interest rate is here, 6% per annum, or 0.06. So, that's 1.06 to the power of N. So we're solving an equation with the variable as the exponent. So the first thing that we need to do actually is just divide both sides by the 5,500. So 8269.97 divided by 5,500, and that is 1.503. Sorry, 1.503. 6 something something something. So that's going to equal 1.06 to the power of N. And seeing as we have done the topic on exponentials and logs, you know how to solve these types of equations. We are going to take the log of both sides, and then using, oh, that should be a 3/6 there, using the log laws, let me see that won't let me go back. Okay, let me scribble it out. Log of 1.5036 ... equals log of 1.06 to the power of N. And using the log laws, we can bring that N down the front of the log. So then you can see that N is going to equal the N, we just have to divide both sides by log of 1.06. So N is going to equal log of that divided by log of that. So log of 1.5036 divided by log of 1.06. And this number that we've got in the numerator here should be the last thing you have on your calculator screen. So you can go fraction button, log of answer, divided by log of 1.06. Close the fraction and press equals, and your N is 7.000 something. So N equals 7. The answer is 7 years. Okay. And I'll leave you with this little cartoon.